My dear students, welcome back to our channel. Students, in this video I am explaining MBA third semester subject Operation Management short questions unit wise. Let's start with first unit. First question. Define production and operation management. Production and operations management, POM, refers to the planning, organizing and overseeing of the processes involved in the production of goods and services. It focuses on efficiently managing resources, processes, and systems to achieve the organization's objectives and deliver high-quality products or services. It is a key function within an organization that is responsible for transforming inputs, such as raw materials, labor, and capital, into outputs, finished products or services. Key aspects of production and operations management. 1. Production management. This involves the planning, coordination, and control of the production process. It focuses on ensuring that the production of goods happens efficiently, on time, and within budget. Tasks include managing production schedules, inventory control, quality control, and maintenance of equipment. 2. Operations management. This is a broader function that encompasses managing the overall operations of an organization. It deals with designing, controlling, and optimizing the processes that produce and deliver goods and services. It includes activities such as resource allocation, workflow optimization, process improvement, and customer satisfaction management. Next important short question is: the scope of operations management is broad and encompasses various activities related to the production and delivery of goods and services. It involves the design, management, and improvement of processes, resources, and systems that enable an organization to meet customer demands efficiently and effectively. Summary. The scope of operations management is expansive and covers all aspects of producing goods and delivering services. It involves everything from planning and designing processes to managing resources, inventory, quality, and customer satisfaction. By overseeing these areas, operations management ensures that organizations run efficiently, reduce costs, and meet customer needs effectively. Next important short question is: service manufacturing is a term that blends elements of manufacturing and service industries, although it's somewhat of a misnomer as services themselves are intangible. However, it is often used to describe the concept of service production or service delivery in the context of the operational and managerial processes that are similar to manufacturing activities. These processes involve creating or delivering services in a structured, efficient, and standardized way. Examples of service manufacturing: fast food chains, hotels and resorts, call centers, healthcare providers. Conclusion. Service manufacturing refers to the application of manufacturing-like principles to the delivery and management of services. The goal is to enhance efficiency, reduce costs, and provide standardized, high-quality services. It emphasizes the importance of process design, resource management, and consistency to create a seamless service experience for customers. Next important short question is: Agile manufacturing is a production philosophy and approach that emphasizes the ability of a manufacturing system to respond quickly and efficiently to changing customer demands, market conditions, and technological advancements. The key idea is to create a flexible, adaptable, and responsive production system that can produce a wide variety of products in small or large quantities, with minimal lead times and high quality, all while keeping costs competitive. Example of Agile manufacturing. Dell Computers. Dell's manufacturing model is a well-known example of Agile manufacturing. It allows customers to customize their computers online and then Dell quickly adjusts its production processes to build and ship the computers based on the specific orders. This system allows Dell to be highly responsive to customer demand while avoiding the cost of maintaining large inventory levels. Automobile industry. Some automobile manufacturers use agile manufacturing to quickly adapt to changes in consumer preferences, such as producing cars with different features or designs without extensive delays or cost increases. Conclusion. Agile manufacturing represents a shift from traditional, rigid manufacturing systems to a more dynamic, flexible approach that emphasizes responsiveness to changing market demands, customer preferences, and technological advances. It is particularly valuable in industries where customization, speed, and the ability to adapt to shifting conditions are critical for maintaining competitive advantage. Next important short question is: PPC stands for Production Planning and Control. It is a critical function in operations management that focuses on the planning, scheduling, and control of the production process to ensure that goods are produced efficiently, on time, and within cost and quality specifications. The goal of PPC is to optimize the use of resources, meet customer demands, and minimize waste while maintaining flexibility to adapt to changing conditions. Conclusion. PPC, Production Planning and Control, is a vital component of operations management, ensuring that production processes are planned and executed efficiently. It helps organizations meet customer demands, reduce costs, maintain high-quality standards, and adapt to changes in the market. By optimizing resources, streamlining workflows, and providing real-time adjustments, PPC contributes significantly to the overall performance and competitiveness of manufacturing operations. Next important short question is: Aggregate planning is the process of developing, analyzing, and maintaining a preliminary, approximate schedule of the overall operations of an organization. The goal of aggregate planning is to balance supply and demand in the most cost-effective way while meeting customer demands. It is a critical part of production and operations management that helps organizations align their production capacity with forecasted demand over a specific time period, usually from 3 months to 1 year. Example of aggregate planning. Imagine a company that manufactures consumer electronics. In the lead-up to the holiday season, demand for their products increases significantly. To handle this peak demand, the company might use a chase demand strategy by hiring temporary workers, utilizing overtime, and increasing production capacity. After the holiday season, when demand drops, the company might use a level production strategy to reduce overtime, decrease temporary labor, and maintain a steady production rate while using inventory to meet lower demand. Conclusion. Aggregate planning is a vital process for aligning production capacity with market demand over a medium to long-term horizon. By balancing supply and demand effectively, businesses can reduce costs, improve efficiency, and enhance customer satisfaction. The choice of aggregate planning strategy, chase demand, level production, or hybrid depends on factors such as demand variability, capacity constraints, and business goals. Next important short question is: Just-in-time, JIT, is a production and inventory management philosophy that aims to reduce waste, improve efficiency, and decrease production costs by producing goods only when they are needed and in the quantity required. The core idea behind JIT is to eliminate excess inventory, reduce lead times, and streamline the production process. It emphasizes the concept of pull-based production, where each step in the production process is triggered by actual customer demand rather than by forecasts. Example of JIT in action. Toyota Production System, TPS, is one of the most famous examples of a JIT system. Toyota implemented JIT to reduce waste, improve quality, and increase production efficiency. It uses a pull-based system and Kanban cards to ensure parts are delivered exactly when needed on the assembly line without the need for large amounts of inventory. For instance, if an assembly worker at Toyota finishes assembling a part and requires more components, the worker uses a Kanban card to signal the part supplier to deliver additional components. This process helps ensure that Toyota only produces the number of cars required and only the parts that are needed for assembly at each stage. Conclusion: Just-in-time (JIT) is a highly effective production strategy aimed at minimizing waste, reducing inventory costs, and improving operational efficiency by producing goods only when they are needed. JIT requires strong supplier relationships, continuous process improvements, and a pull-based production system. While it offers significant benefits, such as cost savings and improved responsiveness to customer demand, it also presents challenges related to supply chain risks and demand fluctuations. Successful implementation of JIT can lead to better product quality, increased customer satisfaction, and a more agile manufacturing system. Next important short question is: line balancing is a key concept in production and operations management, particularly in manufacturing, where it refers to the process of assigning tasks to workstations in such a way that each workstation has approximately the same amount of work, leading to a smooth and efficient flow of production. The objective of line balancing is to minimize idle time, avoid bottlenecks, and ensure that the production process operates at optimal speed. Line balancing is essential in assembly lines, where multiple tasks need to be performed sequentially on products as they move through various workstations. The aim is to balance the work across all stations so that each one performs an equal or nearly equal amount of work, reducing delays and improving overall productivity. Example of line balancing: imagine a company that assembles a simple product, such as a table, with 5 tasks. The company wants to produce 10 tables per hour, meaning the cycle time is 6 minutes per table. Conclusion: line balancing is a crucial technique in production management to optimize assembly line efficiency, reduce costs, and maintain smooth production flows. By ensuring that tasks are evenly distributed across workstations, manufacturers can increase productivity, reduce waiting times, and meet customer demands more effectively. However, achieving effective line balancing requires careful planning, task analysis, and sometimes sophisticated methods to handle task dependencies and workforce variability. Next important short question is: product design is the process of creating and developing new products or improving existing products to meet customer needs, business goals, and manufacturing capabilities. It involves a combination of creativity, engineering, and market research to transform ideas into tangible, functional, and aesthetically pleasing products. Product design is a multidisciplinary field that integrates various aspects, including functionality, usability, ergonomics, cost, aesthetics, and manufacturability. Example of product design: consider a smartphone. The product design would include functional aspects, ensuring that the phone has the required features, camera, battery life, processing power, and meets performance standards. Aesthetic aspects, the appearance, such as the shape, size, materials, glass, metal, and screen design. User experience, UX, the interface design, operating system, app layout, ease of use. Manufacturability, ensuring that the phone can be mass-produced efficiently, with consideration for materials and assembly processes. Sustainability, designing the phone to be energy efficient, using recyclable materials, and ensuring that it meets environmental standards. Conclusion. Product design is a crucial and multifaceted process that involves creating products that meet customer needs while being manufacturable, cost-effective, and sustainable. It requires a combination of creativity, technical knowledge, and market understanding to create products that are functional, user-friendly, aesthetically appealing, and successful in the market. Effective product design can differentiate a company's offerings, drive customer loyalty, and contribute to long-term business success. Next important short question is: work study is a systematic approach to improving productivity and efficiency in the workplace by analyzing and optimizing the methods and processes used in tasks or operations. It involves the application of techniques to study and improve work performance, reduce wastage, and enhance productivity while ensuring that the work environment remains safe and comfortable for employees. Example of work study. In a manufacturing plant, a company may use work study to improve the assembly line efficiency of a product. By observing the process and using time studies, they find that workers are spending too much time walking to get tools and parts. A method study could suggest reorganizing the workstation layout to bring tools and parts closer to the workers, reducing unnecessary movement. In parallel, a work measurement study could help set a time standard for the new layout, ensuring that workers have a fair and achievable target. Conclusion. Work study is an essential practice in improving operational efficiency, reducing waste, and enhancing productivity across various industries. By focusing on optimizing work methods and accurately measuring work performance, organizations can streamline their processes, reduce costs, and improve the overall work environment for employees. Through systematic analysis and implementation of improvements, work study ensures that businesses maintain a competitive edge while fostering better working conditions and high-quality outcomes. Next important short question is: method study is a systematic approach to analyzing and improving work processes to make them more efficient. It involves evaluating the current methods or procedures used in a task and identifying ways to reduce waste, eliminate unnecessary steps, and optimize the use of resources such as time, labor, materials, and equipment. The main goal of method study is to improve productivity, reduce costs, and ensure that work is done in the best possible way, considering both efficiency and effectiveness. Example of method study. Imagine a company that manufactures shoes. A method study might be conducted on the assembly line to analyze how shoes are assembled. Through observation, it may be discovered that workers are moving back and forth between workstations to fetch tools or materials. The method study might suggest rearranging the workstations so that tools and materials are within easy reach, reducing unnecessary movement. This change would improve worker efficiency and reduce production time. Conclusion. Method study is a powerful tool for improving efficiency, reducing waste, and enhancing productivity in various industries. By systematically analyzing work processes and eliminating inefficiencies, businesses can optimize their operations, reduce costs, and improve quality. It is a continuous process that requires regular evaluation and refinement to ensure long-term success and competitiveness. Next important short question is: facility layout refers to the arrangement of physical resources such as equipment, workstations, machinery, and materials within a facility, such as a factory, warehouse, office, or retail space, to maximize efficiency, minimize costs, and improve the flow of goods or services. The layout determines how effectively resources are utilized, how materials move through the production process, and how employees interact with each other and the equipment. An effective facility layout is crucial for optimizing workflow, reducing transportation time, improving safety, and increasing overall productivity. The layout design directly influences operational costs, work quality, and employee satisfaction. Example of facility layout. In an automobile manufacturing plant, a product layout would be used where the assembly line is arranged so that each car progresses through the production process in a continuous flow. Workstations would be arranged in sequence, example, welding, painting, assembly, inspection, with minimal movement of materials between stations. This layout ensures efficiency and reduces time between operations, leading to higher productivity in mass production. Conclusion. The facility layout is a critical aspect of operations management that directly impacts the efficiency, cost, and safety of production or service processes. By carefully considering factors such as product type, production volume, technology, and workflow, companies can design layouts that optimize the use of resources, improve productivity, and ensure smooth operations. Whether for manufacturing, warehouse, or service industries, an effective facility layout plays a vital role in achieving operational excellence and business success. Next important short question is: maintenance management refers to the process of planning, organizing, and overseeing the activities required to maintain equipment, machinery, facilities, and infrastructure in a good working condition. The primary goal of maintenance management is to ensure that assets are maintained efficiently and effectively to minimize downtime, prevent costly repairs, and maximize their operational life. Maintenance management encompasses several functions, including preventive maintenance, corrective maintenance, predictive maintenance, and routine inspections, all aimed at achieving optimal asset performance and supporting the overall production process. Conclusion. Maintenance management is a crucial aspect of operations that helps organizations ensure the continuous, efficient, and safe operation of equipment and facilities. By employing strategies such as preventive, predictive, and condition-based maintenance, companies can extend the life of their assets, minimize unplanned downtime, and reduce maintenance costs. An effective maintenance management program leads to better asset reliability, improved safety, and ultimately, enhanced operational performance. Next important short question is: Total Quality Management, TQM, is a comprehensive and organization-wide approach to improving the quality of products and services through continuous improvement, employee involvement, and a focus on customer satisfaction. The central idea of TQM is that quality improvement is not just the responsibility of a specific department, such as quality control, but should involve all employees, at all levels, and in all areas of an organization. TQM emphasizes customer satisfaction as the ultimate goal, and it aims to improve processes, reduce waste, and ensure the highest level of product or service quality. It involves a systematic and strategic approach to achieving quality goals and integrates quality control, quality assurance, and quality improvement activities into every aspect of business operations. Conclusion. Total Quality Management, TQM, is a holistic and systematic approach to improving quality across all areas of an organization. By involving every employee and focusing on customer satisfaction, continuous improvement, and data-driven decision-making, TQM helps organizations achieve higher quality, lower costs, and better customer relationships. While there are challenges in implementing TQM, the benefits of improved product quality, employee engagement, and competitive advantage make it a powerful strategy for any organization seeking long-term success. Next important short question is: preventive maintenance, PM, refers to the proactive approach of performing regular, planned maintenance activities on equipment, machinery, or systems in order to prevent unexpected breakdowns, extend their operational life, and maintain optimal performance. The primary goal of preventive maintenance is to identify potential issues before they lead to failures, ensuring continuous operations and minimizing costly repairs and downtime. Preventive maintenance is carried out on a scheduled basis, rather than waiting for the equipment to fail. It typically involves activities such as inspections, cleaning, lubrication, adjustments, and parts replacement, all aimed at keeping assets running efficiently. Conclusion: preventive maintenance is a critical strategy for maintaining equipment reliability, safety, and efficiency in a wide range of industries. By proactively addressing potential issues before they result in costly repairs or downtime, preventive maintenance helps organizations optimize their operations, reduce maintenance costs, and extend the life of their assets. When implemented effectively, preventive maintenance improves productivity, enhances safety, and contributes to the long-term success of the organization. Next important short question is: EOQ, economic order quantity, is a formula used in inventory management to determine the optimal order quantity that minimizes the total cost of inventory management. These costs include the costs of ordering inventory, ordering costs, and the costs of holding inventory, holding or carrying costs. The goal of EOQ is to strike the right balance between ordering too frequently, which increases ordering costs, and ordering too much at once, which increases holding costs. Formula for economic order quantity, EOQ. The EOQ formula is: EOQ is equal to DSH, where D is equal to demand for the product, usually in units per year. S is equal to ordering cost per order, fixed cost each time an order is placed. H is equal to holding cost per unit per year, cost to store 1 unit of inventory for a year. Example of EOQ calculation. Assume a company has the following values. Conclusion: economic order quantity, EOQ, is a valuable inventory management tool that helps businesses determine the most cost-effective quantity of inventory to order. By balancing ordering and holding costs, EOQ helps businesses maintain optimal inventory levels, reduce excess costs, and improve overall efficiency. However, to be most effective, it should be adapted to the specific needs and dynamics of the business, considering factors like demand variability, lead times, and cost changes. Next important short question is: selective inventory control is a technique used in inventory management to categorize and prioritize inventory items based on their importance, value, or usage. The idea behind selective inventory control is to apply different levels of management attention and control to different groups of inventory items, rather than treating all items the same. This approach allows businesses to allocate resources more effectively by focusing on the most critical items while using less effort on items that are less important. Conclusion: selective inventory control helps businesses manage their inventory more effectively by categorizing items based on value, demand, or criticality. Techniques such as ABC analysis, WAID analysis, and FSN analysis allow businesses to prioritize high-value or high-importance items while reducing focus on low-priority products. This approach results in better inventory management, cost savings, improved efficiency, and enhanced customer service by ensuring that the right inventory is available at the right time. Next important short question is: safety stock is the extra inventory that a company maintains to mitigate the risk of stockouts caused by uncertainties in demand or supply. It acts as a buffer between the expected demand and actual demand, ensuring that a business can continue to operate smoothly even when there are fluctuations in demand or delays in the supply chain. Conclusion: safety stock is a critical tool in inventory management that helps businesses avoid stockouts and ensure they can meet customer demand. It acts as a buffer against uncertainties in demand and supply. However, it must be carefully managed to avoid excessive holding costs, overstocking, or obsolescence. By balancing the need for safety stock with cost considerations, businesses can maintain smooth operations, improve customer satisfaction, and optimize their overall inventory management. A bin card is a manual or digital record used in inventory management to track the quantity, location, and movement of items in a warehouse or store. It is typically attached to a storage bin, shelf, or other inventory holding area, and it provides detailed information about the items stored there. The bin card is an essential tool for monitoring stock levels, preventing stockouts, and ensuring accurate inventory records. Example of a bin card. A typical bin card might have the following columns. 1. Date, the date of transaction. 2. Receipt issue, whether the stock was received, incoming goods, or issued, outgoing goods. 3. Quantity, the number of units received or issued. 4. Balance, the remaining stock balance after each transaction. 5. Reference, a reference number for the transaction, example, invoice number, production order. 6. Remarks, any additional notes or comments related to the transaction. Conclusion: a bin card is a useful tool in inventory control, helping businesses track stock levels, monitor stock movements, and prevent errors or discrepancies in inventory records. Whether physical or digital, bin cards ensure that inventory management processes are more organized and efficient, ultimately leading to better control over stock and improved operational efficiency. Next important short question is: double bin system. The double bin system is an inventory control method used to manage stock efficiently by maintaining two separate bins or storage locations for each inventory item. This system ensures that businesses always have enough stock on hand to meet demand without running out or overstocking. Example: let's say a company uses the double bin system for an item and it maintains two bins. Bin 1, active bin 50 units. Bin 2, reserve bin 100 units. When bin 1 reaches 0, the company will switch to bin 2 and reorder enough stock to fill bin 1 back up to the required level. Meanwhile, bin 2 will be replenished during this time, ensuring that the company doesn't run out of stock. Next important short question is: store's ledger. A store's ledger is an inventory record used to track and maintain details of goods received, issued, and on hand. It is a manual or electronic record that helps businesses monitor their inventory levels and control stock movements over time. The store's ledger is usually maintained for each individual inventory item in the organization. Conclusion: both the double bin system and the store's ledger are essential tools in inventory management, but they serve different purposes. The double bin system helps maintain a continuous supply of stock by using two bins per item, ensuring stock availability and minimizing stockouts. On the other hand, the store's ledger provides a detailed record of all stock movements, allowing for more precise tracking of inventory levels and better control over stock management. By using these systems together, businesses can improve inventory accuracy, streamline operations, and ensure that they have the right quantity of stock available at the right time.